Okay, ji, Bismillahirrahmanirrahim. Am I audible, beta?
Yes, ma'am.
Hello, come towards the query. Your first query about the, I do not know the exact variant and paper number, but I know that it's from 2023 paper, but the rest of the information I will give you later on. So this is a question which is given by you, how to solve this question. So the enthalpy change for the neutralization of nitric acid with sodium hydroxide is minus 57.0 kilojoule per mole. So in an experiment, 20.0 centimeter cube of what informations we have? We have the 50.0 kilojoule per mole for the sodium hydroxide, and we have 20.0 along with 4.0 mole per decimeter cube of nitric acid. Similarly, the volume and concentration of sodium hydroxide is given. It can be assumed that the heat capacity of the product mixture is 4.2 joule per centimeter cube per degree centigrade, and that there are no heat losses. What is the maximum final temperature of the mixture? So we have to move on towards this question, how to solve this question. First of all, we have to look at the information which is given to us. First, we will calculate Q, that is MC delta T. So first of all, we will see what we have. We have the volume of, let me write here. We have the volume, that is volume of HNO3, and we have the volume of NaOH. Can you see? Is it the part of the, let me check, it is going to be captured? No, it's not going to be captured over there. I have to write it here. First of all, we will see about the nitric acid, the data which is given to us for the nitric acid and for the sodium hydroxide. So if we were going to talk about the volume, for the volume given for the nitric acid is 20.0 centimeter cube with the concentration that is 4.00 mole per decimeter cube, whereas sodium hydroxide volume is 30.0 with the concentration 2.00 mole per decimeter cube. So here is the volume given in centimeter cube. Now can we calculate the number of moles for it? Take the
Yes,
calculator.
ma'am.
Quickly take the calculator. We have to calculate the moles. In order to calculate the moles, concentration into volume, concentration is given, that is 4.00 into 20.0 divided by 1000. We have to convert this value into decimeter cube. So what is the answer?
Ma'am, the answer is 0.03 moles.
0.0
3 moles.
20.0 divided by 1000 multiplied by 4.00.
Yes, ma'am, 0.03 moles.
03 moles. And what about the 330.0?
0.06 moles.
30.0 multiplied by 2.00 divided by 1000. What is the answer?
0.06 moles.
0.06 moles. So you have calculated the exact values?
Yes, ma'am.
Okay. Now, do you know that M is basically the sum of the volume, if we talk about the sum of the volume over there? Okay.
Yes, ma'am, it will be 50.
It will be the, for the nitric acid, have we taken the same values? Let me check. Nitric acid, it's 20.0 with 4.0 mole per decimeter cube, 30.0 with 2.00. Divided it with 1000. 20.0 divide it with 1000.
Yes,
Then
ma'am.
multiply by with 4.
It's 0.08.
I feel little bit confusion here कि इसके आंसर में कोई तो इशू आ रहा है. There is the question. Yes. 0.0
0.08.
8 moles. Okay. Okay, 0.08 moles. Now come towards the next question. So here this was the way through which first of all will have to calculate the number of moles. Now come towards the if we are going to write the mass, basically the volume which we have to collect it 20.20 plus 30. This is the volume which is given to us. Multiply by C value is given to us. Do you know what is the value? 4.2.
Yes, ma'am.
And we have to calculate delta T. Q is equal to 20 plus 30, 50. Let me write the
Ma'am, initial temperature is given for both solutions.
yes, I will give you the answer. Wait. Yes, ask the question.
Ma'am, initial temperature is given for the both solutions, so we
Yes.
have to find the final
Final
temperature.
temperature. We have to find the final temperature. As you know that in the question they have given us the enthalpy change of neutralization. Acid and alkali is
Yeah.
going to react, which is the value which is given to us. Let me check. Let me highlight where it is.
So, ma'am, which moles will we take
This one.
of NaOH or NHNO3?
The limiting one.
Yeah,
the limiting one.
the limiting one.
You have to find
So,
out the
the
number.
limiting one is NaOH. So, we will take the moles of NaOH.
Yes, we will take the number of moles of NaOH. So this one is the 57.0 kilojoule. Can you see it?
Yes, ma'am.
Let me. Okay, let me move on. So we will take the number of moles for it. So the very important thing which you have to focus on here about the, let me change the color. About this, enthalpy change is given to us and number of moles, 1 mole, we have the values here. We have enthalpy change 57.0 which is given to us in 1 mole. So the limiting one we will take in 0.06. We can calculate the enthalpy change here. So what is the answer? Quickly answer. 57.0 multiplied by 0.06.
Minus 3.42.
Minus 3.42.
42.
Answer will be in kilojoules. So what we will have, how can we convert kilojoule into joules?
Multiplied by 1000.
Yes, multiply this value by 1000. Minus 3.42 multiplied by 1000. What will be the answer? It will be 3420. Yes,
3420.
joules. Answer will be in joules. Now come towards the next part. So Q is equal to MC delta T. Now we can write it here. Delta H is equal to, we can write it here. Delta H is equal to MC delta T. Now we have to put the values here. 3420 joules is equal to 50 with the value multiply by with 4.2. We have to calculate delta T. So what will the value? First of all, calculate get the answer of it. 3420 divided by 50 into 4.2. What is the answer?
16.285.
16.285.
Yeah, ma'am.
So this will be the answer for our delta T. So delta T means final. Let me change the color. Delta T means final temperature minus initial temperature.
Yeah.
Okay. So if we will have the value of initial temperature, that is minus 25 degrees centigrade. Sorry, 25 degrees centigrade. Final is equal to 16.285.
Yes, ma'am.
Okay, so get the answer. Final 16.285 plus 25. What is the answer?
Ma'am, we got 41.285. The final temperature.
41.285. So let me check what can be the answer.
Ma'am,
41.2 means
41 point,
41.3.
41.3, yeah.
Is it correct?
Yes, ma'am, it's correct.
Okay. So this was a question which we have done here. Now, yes, some bond energies are listed. 1 mole of hydrogen reacts with oxygen to give water vapor. Okay, using the bond energy data, what is the value for the enthalpy change for this reaction? Either you have to complete it with all of the reaction and with half of the oxygen atom. Better to do completely and then you can divide it into 1 mole. If we can write the equation for the reaction with hydrogen plus oxygen, because in the reaction you can see 1 mole of hydrogen reacts with oxygen to give water vapor. So basically this is the question which we have to follow on. 1 mole of hydrogen, 1 mole. Focus on 1 mole of hydrogen reacts with oxygen to give water vapor. So you can complete all of the questions with the original values, then divided it by 2, or you can move on like this. O2, it will give us water vapors, that will be 2H2O. So it can be, yes, you have given the exact for H2 half O2 and 1 H2O. You can use the values and put the values here. But remember one thing, always you do such kind of mistakes, you have to focus on how to do these questions. First of all, we have to check the values for the reactants. If I will write the value, let me completely do it, then I can proceed on with 1 mole. First of all, I will solve it with the original values. 2 values के साथ भी कर सकते हो. You can do it with the one with the half oxygen as well. So if I will go with the 2 hydrogen atoms will be there plus 1 O2, it's going to give us 2 OH and OH bonds. So now come towards the values. 2 multiplied by the value for HH is 436 plus for O2 496. These are the values for the reactants, and then the values for the products are 1 OH and then another OH. In one molecule there are 2 OH, so in 2 molecules it will be 4 OH. So you have to take the values. 4 multiplied by OH is 463. So multiply these values. 2 multiplied by 436.
Ma'am, 872.
Okay. Eight.
872.
872 for the reactants. And what about the products? 4 multiplied by 63.
Ma'am, 872 for the, you can say, the hydrogen, like hydrogen bond, 2 multiplied by
plus
HH
496.
Okay, 872 plus 496.
Plus 496.
1368.
872 plus 496. So answer will be
1368.
68. So what about the H2? 4 into 463.
Yeah, 463. It's 1852.
1852.
Yes.
Okay. So here are some of the parts which we have done. These are the energy changes for the reactants, and we will say each can the H1. This one is for the product H2. What we will do, we will write the values like this: H1 plus H2. H1 is the heat energy for the absorb to break the bonds for the reactants, so it will be always with the sign of plus. Whereas product where energy bonds will form, the sign will be minus. So I'm going to write the values of H1, that is plus 1368 plus minus the value for the 1852 for the H2 is the product when bonds are formed and energy is released. So when energy is released, the sign for the exothermic reaction is minus. So overall change in on the reaction, we will calculate it. Plus, minus, minus, what will be the answer? Minus
1852 minus 1 minus 484.
484. So this was the answer for the 2 moles of water molecules. So we have to divide it by 2 because we needed to get the answer.
242.
Yes, we have to divide it by 2. The answer will be 242. So minus 242 will be the answer.
So ma'am, here we have taken the product as minus and
Yes.
reactant as positive.
Exactly. Whenever the new
So
bonds are
this will
formed,
be reactant minus product
yes, reactant plus product.
plus product.
Plus
Okay.
product, but sign value with the product will go with the minus charge.
Okay.
Okay, I hope so that
Yes.
you have learned it very well. So if you will have any queries, send
So
it to
ma'am,
me.
it
Yes,
is
yes.
in the case of enthalpy change of reaction.
Gee, this is in case of enthalpy change of reaction when you are finding out the overall enthalpy change of the reaction.
Okay, overall enthalpy change of the reaction. So we will take the product as minus.
Always take,
Oh.
you know that at the reactant first bonds will be broken down. Whenever the bonds will be broken down, heat energy will be absorbed. When energy will be absorbed, bonds will be broken down. When energy will be released, bond will be formed.
Yes.
So enthalpy change tell us when more is this reaction is exothermic, and this exothermic reactions tells us that the more energy released than absorbed in bond breaking.
Okay.
More energy released in bond formation than absorbed in bond breaking. So that's why this reaction is exothermic. Clear?
Yes, ma'am, clear.
Okay. Any further questions I will see? I hope so that you have learnt it very well. So see you tomorrow. Till then, Allah Hafiz.